Jai Hind to all. Myself Manoj Kumar Sharma, Assistant Professor in Computer Science and Engineering Department, Ajay Garg Engineering College, Uttar Pradesh. Today we will discuss data warehouse and data mining. The code is BCS 058. The topic covered today in lectures. First one is mapping the data warehouse to multiprocessor architectures, shared memory architecture, shared disk architectures, and shared nothing architectures. The main second topic is multi-dimensional data models. Basically, there are 4 types of dimensional models used in data warehouse and data minings. First one is data cubes, star schema, snowflake schema, and fact constellation schema. Now, mapping the data warehouse to multiprocessing architectures. Why we map the data warehouse into a multiprocessing architectures? Basically, it is used to speed up the data and scale up the data. Means distributing the workload across multiple processor handle to large scale of data sets. We have a large scale of data sets in data warehouse and data minings. So we use to multi-processing, parallel processings. So there are 2 advantages of in parallel relation database technology for data warehouse. First one is linear speed ups. It refers to ability to increase the number of processor to reduce the response time. If we have a multiprocessors environments, so many processors, number of processors working on parallel modes. So we use to reduce the response time for fetching the queries or data. Size. So we need to use the multiprocessor architectures according to the requirements. Now these are the some key components basically used in multiprocessing architectures. First one is data warehouse. It is a central repository where large volume of data are stored and analyzed. Second key component, systems. A system with multiple processes to divide and conclude tasks in parallel modes. If we use the multiprocessor systems and architecture, so query and data execute in divide and conclude problems, means problems divided into subproblems and these subproblems divided into multiprocessors, and these processors work on parallel modes. Third component is ETL process. ETL means extract the data, transformation of data, and loaded the process and loaded the data in the data warehouse. In multiprocessor setups, the ETL process can be parallelized to make the data integration faster. So we can easily extract the data from different data sources, and we can easily transformation of data like reduce the redundancy, maintain the consistency, organize the data in proper manners. Third component is parallel processings. In multiprocessor architectures, each processor in multiprocessor architecture handle the portion of data or computation speed of the relational queries and processings. Next component is distributed storage. Data is partitioned and distributed across multiple nodes. Nodes means systems, multiple processors, and each node process in portion in concurrently and parallel environment. Basically, 3 types of DBMS architectures used in parallel processings. First one is shared memory architectures, means memory basically used in shareable mode with all multiprocessors. Shared disk architectures and shared nothing architectures. Shared nothing architecture basically show there is no memory in shareable mode and no disk in shareable mode. Means each and every system has its own memory and own CPU. Now, first one is shared memory architectures. This is the architecture diagram of shared memory architectures. This is the interconnection network, and these all are multiple processors, means PU, processor units, are share the global shared memory and connected with the disk. This is the disk 1, disk 2, disk 3 and disk 4. Means multiple processor units share memory, and each processor unit has full access to all shared memory through common bus, and communication between node through shared memory. Means in shared memory architectures, queries, fetches by the users and data analysis use the shareable memory in shared memory architectures. Second is shared disk architectures. Means there is no memory in shareable modes, only disk is basically used in shareable. Means these all are the disks shared by the common global shared disk subsystems, and each and every processor have individual local memory and connected with the shared disk subsystem. Basically, it is the architecture of shared disk systems used in multiprocessor architectures. Multiprocessor means number of processors are used. This is the processor unit 1, this is the processor unit 2, this is the processor unit 3, and this is the processor unit 4. Means multiple processors. Multiple processors used in multiprocessing architecture environment and connected with the shareable global disk, and each and every processor and system and nodes has its own local memories. So this is the basic common architecture of shared disk architectures. Memory is not shared between nodes. This memory is not shared between nodes. Each nodes have a individual memory. Second, communication occur over communication high speed bus. This is the high speed bus, and communication basically used through the high speed bus. And each node has access to the same disk and other resources. These all the disks are connected with the all processor with the using of shareable disk bus systems. And last architecture is shared nothing architectures. Basically, shared nothing architecture is an example of distributed systems. What distributed system? Each and every system has its own memory and own CPU. Means individual nodes have own CPU and own memory. This processor is own memory and own CPU, and this processor also own memory and own CPU. And similarly, this processor have a own memory. Means each processor and system and nodes have same memory and individual local memory and shareable mode. So we can say that in the shared nothing architecture, each and every system has its own memory and own CPU. Basically, two limitations are occur in this case. First one is first limitation is non-shareable memory is available, global clock and shared nothing architectures. So in shared nothing system, only CPU is connected to a given disk. If a table or database is located on the disk, access depends entirely on the CPU which owns it. So this is the shared nothing architectures. Now second topic is covered in this lecture is dimensional modeling. What is dimensional modeling? Basically, data in warehouse are usually multi-dimensional, having measures and dimensions. What is measures? Measures means quantitative. Quantitative means numbers, means units, and dimensions means basically qualitative, descriptive. The main goal of this modeling is to improve the data retrieval, so it's optimized for select operations. If we have a data in multi-dimensional architectures, so we can easily fetch and retrieve the data from the database sources and data warehouses. What is measures? Measures some value can be aggregated upon those values like sum, maximum, minimum, average, and so on. Similarly, in dimensions, that define the dimensions on which the measures attributes and their summary functions of work, like qualitative descriptions. Now, basically two things is used in multi-dimensional database models. First one is fact tables and second one is dimension table. First one is fact tables and second one is dimension tables. Fact tables basically considers the quantitative values and dimension tables basically consider the descriptive values. Fact are the measurable data elements that represent the business metrics or interest. For example, in a sales data warehouse, the fact might include sales revenue, units sold, and the profit margins. Means all these things are in units and numbers. So each fact is associated with one or more dimensions, creating a relationship between the fact and the descriptive data. Now, what is fact table? Fact table is the central table that contain the measures and metrics of the interest surrounded by the dimension tables that describe the attributes of the measures. These dimension tables are related to the fact tables through foreign key and relationships. Second one is dimension. What is dimensions? Dimensions basically consider the descriptive data. Like in fact table, we have a sold units. If any product, so this is the fact, and this attribute consider in fact tables. And what is dimension? So product name, product model, and any other descriptive information, it basically occur in dimension and dimension tables. So see, dimension are the descriptive data elements that are used to categorize or classify the data products. For examples, in a sales data warehouse, the dimension might include product, customer, time and locations. These all are the descriptive data, and each dimension is made up of a set of attributes that describe the dimensions. For example, the product dimensions might include attributes such as product name, product category and product price. This is called the dimensions of attributes that are included in the fact tables. And what is dimension tables? Basically, dimension of a fact are mentioned by the dimension tables, and they are basically joined by a foreign key. Dimension table are simply denormalized tables. The dimension can be having one or more relationships. Now, these are the elements of the dimension tables. Like this is the structure of fact table and dimension table. What is fact table and dimension table? This is used in the data warehousing architecture and schemas. This table is known as fact table, and these all are the dimension table. These are the dimension table. Dimension table. So we see the product key, time key, store key, order dollars and order quantity. All these are quantitative and numbers, which is included in the fact tables. But you see in dimension tables, the date, day, month, city, store name, phone number, product name, brand and color. These all are the dimensions of those attributes that are included in the fact tables. So time key is here, and time key is descriptive manner like date, day and time. Store key in fact tables, and where is store, city, store name and phone numbers. These all are the descriptive attributes, means qualitative data, and these all are the qualitative data basically used in the dimension tables. Now, multidimensional data models. How many type of multidimensional data models used in data warehouse? There are 4 type of data models used, multidimensional data models used in data warehouse. First one is cuboid, second star schema, fact constellation schema and snowflake schemas. Now we discuss all the schemas one by one. The multidimensional data model allow for the efficient, organize, analyze for data from various perspectives. Multidimensional means if we have a data in large scales, so we need to organize the data in a proper manner in sequential channels, like attributes wise, like product wise, like categorized wise. So we can easily fetch and retrieve the data from the large scale of databases and data warehouses. So multidimensional data model is a method which is used for ordering of data in the database along with good arrangement, assembling the content in the databases without any inconsistency in the databases. So we need to manage the database should be in consistent state, and we need to required reduce the redundancy of the database in the data warehouse. First multi-dimensional model is data queues. It represents data in the form of data cubes. Data cube allow basically view the data from many dimensions and perspectives. This is the architecture of data cubes. Now we explain the architectures. One attribute is product, second attribute is time, third attribute is locations, means multiple dimensions used in the databases. So we can easily retrieve the data according to the user requirement with the using of all the credentials used in the data cubes. If we required the single products information like refrigerator, what are the sale of refrigerator in a second quarter and third quarter in a particular location. So we use the three dimensions. First dimension is product, second dimension is time, and third dimension is the locations. So it is the multi-dimensional data models. We can easily fetch and retrieve the data according to the data cubes attributes. Now second is star schemas. Basically it uses fact table and dimension tables. I already explained what is fact table and what is dimension tables. Fact table basically use the quantitative data and dimension table basically consists the qualitative data. So star schema is a collection of database objects including tables, view indexes and so on. The star schema is a type of multi-dimensional model used for data warehouse. In a star schema, data is organized a central fact table that contain the measures, matrix, quantitative data, numbers of interest surrounded by the dimension tables that describe the attributes of the measures. So this is the fact table and these all are the dimension tables. So fact table in a star schema contain measures and metrics that interest of user organizations. For example, in a sales data warehouse, the fact table might contain sales revenue. It is also in quantitative data, unit sold, quantitative data and numbers, and profit margins. It also margin in numbers. Each record in the fact table represent a specific event or transaction such as a sale or orders. Now in dimension tables in a star schema, these attributes are used to slice and dice in data in the fact tables, allow user to analyze the data from different perspectives. Like we already consider the sales data in fact table. So explain the dimension table according to the sales data. The dimension table might include product, customer's name, time and locations. These all are the descriptive data of attributes that are used in the fact tables. This is the basic architecture of the star schema. This is the fact table, and these all are the dimension table. These are the dimension table. Product ID, these attributes consist in sales fact tables, order ID, customer ID, employee ID, total quantity and discount. These all are the quantitative data. Product name, product category, unit price, employee name, title, department, region, customer name, address, city and zip, order date, year, quarter and month. These all attributes consist the descriptive data, descriptive and qualitative data. So this is the basic architecture of star schemas. Now second schema and multi-dimensional architecture is snowflake schema. In snowflake schema is a type of data model where the fact table link normalized dimension tables split into multiple related tables. Means only one fact table used in the center in snowflake schema, but in case we have a 4-dimension table, so we need to divide the dimension tables further sub-dimension tables. Means we use the normalization of the data in the Snowflake schema. We use more organizing, more specific, more structured data in the Snowflake schema. So, we can easily retrieve and fetch the data with the using of Snowflake multidimensional schemas. A Snowflake schema design occurs when a dimension table is further normalized by splitting low cardinality attributes into separate related tables. These are linked using foreign keys. Means one dimension table is connected with the another dimension table with the using of foreign keys. This is the basic architecture of the Snowflake schemas. First, sales. This is the fact table. Fact table. This is the dimension table. And this is the sub dimension table of dimension table 1, sub dimension table 1, dimension table 2 and sub dimension table 2, dimension table 3 and sub dimension table of 3. We see here these all attributes are quantitative, means numbers like order ID, product ID, customer ID, employee ID, total sale, quantity and discount. These all are the numbers, and in dimension tables all attributes are in descriptive manner like product name and product category. So, we use the sub dimension tables with more normalizations of data because of reduce the response time according to the user requirement and query fetching. So, product name, product category ID, description and unique price, means this dimension table further normalize into the sub dimension tables in Snowflake schemas. Second case is employee dimensions, product, employee ID, employee name, department ID, region and territory. So, this dimension tables already divided into sub dimension tables. Department ID here, you check the department ID, but we use this department ID further normalized, means department name and department locations. So, we used to more normalize the data in the Snowflake schemas. Now, third one is fact constellation schema, multidimensional models. Fact constellation schema integrate multiple fact tables. In previous Snowflake and star schema, we use the only one fact tables situated in the center of the multidimensional architectures. But in case of fact constellation schema, more than one fact tables used in the architectures. Integrate multiple fact tables sharing common dimension, often referred to as a galaxy schema. We can say galaxy schema, like so many fact tables, so many dimension tables are gathered here in the multidimensional architecture. So, we used to say the galaxy schema for fact constellation schema. Basically, this approach allow in business to conduct multi-dimensional analysis across complex data sets. If we have a complex data, if we have a large scale of data, multi-dimensional data, so we use to fact constellation schema because of we use the more than one fact tables in the multi-dimensional architectures. This is the basic architectures, fact table 1, fact table 2 and these fact table associated with the same dimension tables. This is the more structured diagram of the fact constellation schema and architectures. This is the fact table placement and this is the fact table 1 and fact table 2. This is the placement fact table and this is the workshop fact tables. And all these fact tables bifurcate and associated with the dimension tables, and these dimension table associated with the common fact tables. So, these all are the multi-dimensional architectures and models basically used in the data warehouse. Now, here some benefits of fact constellations schemas. First one is enhanced query performance. If we use normalize the data, if we use the more than one fact table, so we can enhance the query performance, reduce the response time. If any user required to fetch the data and required to fetch the data analysis, so we use the fact constellation schemas. Second is flexibility in reporting and analysis. We can easily report and analyze the data according to the fact constellation architecture and schemas. It offers Flexibility in reporting by connecting multiple fact tables to common dimension, allowing dynamic and customizable aggregations of data across different business matrices. One more advantages of fact constellation schemas. Third one is improve scalability. If we need to improve the data warehouse scalability, so we use to fact constellation schemas. Fact constellation schema efficiently handling the large data set by distributing data across fact tables and shared dimensions, ensuring scalability as data volumes grow. If we have grow the data volume, so we use to fact constellation schema, so easily we can fetch and analyze the data according to this concept. Simplified data management. It is a modular approach, basically support partitioning, simplifying maintenance and optimize the storage while allowing easy update without disrupting the data models. Means this type of data multidimensional architectures maintain the consistency of data, reduce the redundancy of data and normalize the data. So we can easily find out the data and query fetching tools. Enhance the data consistency. Now see, this data architecture basically enhance the performance of the databases and reduce the redundancy of data and also maintain the consistency. And last advantage is support for complex analytical queries. In starting, I always say it is basically used to complex data sets. It facilitates complex analysis by enabling cross-referencing and aggregation from multiple fact tables, providing comprehensive insights, especially useful in industry like retail, finance and health sectors. So here we study and some topics like multi-dimensional data models, and second is star schema, snowflake schema, and most important point is how to map the data warehouse into a multiprocessor architectures. So this is the important topic in data warehouse and data mining. Thank you, friends.